20, which is integration techniques, where we will study use substitution in today's video of different types of functions. So if you remember clearly, what is use substitution is basically integration technique. So if you remember clearly from before, if you have a function f of x, right, which is 2x minus 1, let's just say 2x squared minus 1 to the power 10 plus c, right? And if I find the derivative of this function, right, if I try to find the derivative of this, obviously I need to use the chain rule. So if I try to use the chain rule, obviously the 10 goes to the front, 2x squared minus 1, take away 1 from the power, right? And derivative of the inside, which is 4x, right? And the derivative of constant is 0. So that's out. If you try to simplify this function, it is 40x into 2x squared minus 1 to the power 9. Now, we need to get back from here to the original question, right? So we say, here's a question we're going to create. We say, okay, what is the integral of 40x 2x squared minus 1 to the power 9 dx? Okay, so this is a case where we apply u substitution. Now, what is u substitution? You must try to see which is the more complicated looking function. The complicated looking function is a function that has this brackets, which is 2x squared minus 1. Another thing that you need to notice inside the integral, that the derivative of the higher function exists and is within the integrand. What's the integrand? All these things inside the integral, right? Make sure that the derivative appears in the integrand. So what's the derivative of 2x squared minus 1? It is 4x. So the x appears there. Or what I usually say is we have a higher power and we have one power less. See, x squared is a higher power and the power less is x. Okay, if you're looking at the order of the polynomial. So we can clearly see you need to recognize integrals of this form. If you recognize integral of f prime x, right, f of x dx, okay? If you recognize the integrals of this form, then we try to apply u substitution. So what is u substitution? We call this, we say let this function equal to u. So we say let u equal to 2x squared minus 1. Not to the power 9, just 2x squared minus 1. Right. Now, after you find this, what you have just done is you have created two equation. You have substituted this, right? You said u is equal to 2x squared minus 1 to the power 9. No, not 9. 2x squared minus 1. You need to find the derivative of u. So you're going to say du dx, right? So this is equation 1. And equation 2 is the derivative du dx. Because what you are basically doing is you are transforming this integral from dx to du. So du dx is 4x, okay? Now, what I will do is I will take this dx across. It's just cross multiplying, right? So therefore, du is equal to 4x dx, right? It's like 4x times dx. Now, there's my second equation here. Now, I need to take equation 1 and equation 2 and substitute it into my integral. So now my integral becomes integral of, leave the 40 as it is, don't worry about the 40. Right, we need to know what is x dx. We know 2x squared minus 1 to the power 9 is already u to the power 9. Leave the 40 as it is. Now, my question is, what is x dx? So the only thing that we are left with is x dx. And to find x dx, we use the second equation, okay? Because equation 1 is used up. I said equation 1, I substituted here, 2x squared minus 1. 2x squared minus 1 is u to the power 9. Okay, this is done. Equation 1 substituted. Now, I need to substitute equation 2. So can I see x dx? What is x dx? I see x dx in my integrand. X dx. What is x dx? That is du over 4. So I'll write here times du over 4. Now I need to neaten up this integral. 40 divided by 4 is 10. Leave the 10 outside. Integral of u to the power 9 du. Now all you need to do is use the power rule. So if you remember the power rule, integral of x to the power n dx is equal to x to the power n plus 1 divided by n plus 1 plus a c. This is
Mr.
the
I don't understand
power rule.
something.
Yes.
Where did you get the du over 4 from?
Yeah. So you see the second equation. You look in the integrand. What do we have left? What we have left is x dx.
Yes.
X dx. What is x dx? Dividing both sides by 4, you'll get du over 4. We're kind of solving for x dx. You understand now?
Why did you divide by 4? No, I still
No,
understand.
you have to. You have to, because I want to know what is x dx. And I can see in equation 2 x dx. What is x dx? It is du over 4. Look at equation 2. Okay, I will solve it for you, all right? If I solve equation 2, I'm solving for x dx, right? What is x
Yes.
dx? It is du over 4. That's what it is. Just dividing
Oh,
both
yeah,
sides
I'm
by
saying
4.
where did you get the 4 from in the first place?
I differentiated this. I differentiated 2x squared minus 1.
Okay.
Right,
Okay, okay.
4x.
Yes,
Are we
yes,
good, guys? Right.
yes.
So now after you neaten up the integral, you get something like this. And now we can just use the power rule, because you make sure that in the integrand you don't have two variables. You can't have x and u both in there. Okay? You can only have a single variable in the integral. It's either x or it's either u. In this case, we are transforming to u, so you must have a u there. So we're going to say 10, leave the 10 as it is. Integrate this, u to the power 10 divided by 10 plus a c. Now what happens? The 10 and the 10 cancels out, and we get an answer. What is u now? U is 2x squared minus 1 to the power 10 plus c. See, we came back to the original question. Are we good? Remember, that's what we started off with. And when I integrated this, I ended up with that. Right. So what is u substitution? Is kind of reversing the chain rule, right? This is chain rule. To differentiate, we're going to use the chain rule. And if you reverse the chain rule, you get u sub. Okay, guys. Now, let's look at some questions that I have here. I do have some questions for you, right? So, as a teaching example. Okay, so I want to solve this question here now. This was just introduction, guys, right? So let's solve this question here, 1A. Let's call it 1. Let's call it 1B. Question 1A. Okay, so let's try to integrate this. So what we're going to do is make this complicated looking function equal to u. So you let u equal to 3x plus 7. What is the derivative? Derivative of 3x plus 7 is just 3. So this is equation 1. Move the dx across, it becomes du is equal to 3dx. And this is equation 2. Okay, cross multiply. So we can transform this integral now. This integral now becomes integral of u to the power 20. What is dx? Dx is du over 3. See, the only thing that I have left, I've substituted this. What is dx? From the second equation, dx is du over 3. neaten up this integral. Okay, you don't have to neaten up. I mean, you can just integrate this. Let's leave the 1/3 as it is. U to the power 21 divided by 21 plus a C. So 3 times 21 is 63, right? It's 1 over 63 into what is U? 3x plus 7 to the power 21 plus C. That's my answer because I substituted the U back. Remember, we need to integrate in terms of dx. So put the function back into x.
Teacher,
Right, so
sorry.
yes.
This the U substitution will work only in the chain rule, yeah?
Yeah.
Okay.
All right, next question. So I made a mistake here. It should be x squared over here, right? Look at this function here. Should be x squared. Now, see if the derivative appears in the integral. So the bigger function is 7 minus 4x cubed. You can make that equal to u. Right, so du, remember the dx, I'll just take it across, okay? And the derivative of this is 0 minus 12x squared, okay? Now, this integral 7 minus 4x cubed is just u to the power 12. Now, what is x squared dx? X squared dx is this part over here. That is x squared dx. And x squared dx is du over negative 12. Okay? Now we can solve this. You can see it always reduces to a power rule. So this integral, let's take out negative 1 over 12 out. That's u to the power 13 over 13 plus c. I think 13, 12, 12 12s are 144 and 12 13s are 156. U is 7 minus 4x cubed to the power 13 plus a c. All right, great guys. Make sense? Now let's move on to the next type of integrals. Yes, you have a question?
No, it's fine.
Next type of integrals is trig integrals, okay? So if you remember your table, the table was sec, tan, cosec, negative, cosec, cot. Now, it's very important to remember these important stuff for trig integrals. Next part. Integral of sine x dx, okay? Integral of sine x dx is negative cos x plus c, because if you differentiate cos, you get negative sine. That's the reason why you need to put a negative cos. Now, if you differentiate cos x, you'll get negative sine x, and negative becomes positive sine x. Integral of cos x dx is equal to, actually not cos x, let's generalize this form. Let's call it sine mx, sine constant, sine of cx dx, right? Cos of cx dx. Right. Okay, so I need to say this is, why did I use a c? Let's call it m. Right, guys, I'm going to read it again. Integral of sine mx dx is equal to negative cos mx over m plus c. You have to divide by m because of u substitution. This one here, integral of cos mx dx is equal to sine mx over m plus c. General rule. So integral of cos, if you differentiate sine, you get cos, okay? So that's the reason why it's like that. Now, what's important here is look at these things now. What did I write for trig integral? You must integrate in pairs. Very important to integrate in pairs. What does that mean? Because when you differentiate, you get the other two. So if you integrate, you can't integrate single, try to integrate in pairs. So what's the integral of, yeah, so how do we apply this table? If I ask you, what's the integral of sec times sec, which is sec squared x dx? It is tan x plus c. Next one, what's the integral of sec tan? So you see, I'm taking a pair. I have to integrate in pairs. Can I either take that pair or this pair? Right? I can't integrate singles because if you try to integrate singles, it becomes more complicated. Integral of sec tan. So make sure you always remember this table. What's the integral of sec tan? Sec tan is a pair, so it is just sec x plus c. So if I ask you what's the derivative of sec, it's the other two. So obviously if you integrate, which is called the antiderivative. Right, so next one, what is the integral of cosec cosec? Remember, I'm leaving out the negative, so I need to add the negative at the end. So integral of cosec squared, it is negative cot x plus c. Yes. And last one, integral of cosec x cot x is going to be negative cosec x plus c. Are we good, guys? So you can clearly see that I didn't integrate anyhow, right? I basically integrated in pairs, right? Now we will do an example of how to integrate tan and cot, but to integrate sec and cosec, we just need a little bit more extra knowledge, right? It is like kind of like u substitution, but we will do it at a later stage. Right, so these are the basic integral types. So now let's have a look at the questions that I have here. Let's have a look at this question and see if you can solve this. Right, so we want to integrate, this is 1C, 1D. Right, so we want to integrate cos t 1 plus sine t, right, dt. So we can see this is a more complicated function. So we make this equal to u. So let u equal to 1 plus sine t. So what is du dt? Remember, you're differentiating with respect to t. Du dt, what's the derivative of 1, 0? Derivative of sine t is cos t. Take the dt across, so you get du is equal to cos t dt. This is equation 2, and that's equation 1. We need to substitute both inside. Now, we want to know what is cos t dt. Great. Cos t dt already appears in the integral. See there? Cos t dt
Mr. Y,
is
why?
right here. What do you mean?
Isn't the integral of the whole function, isn't it just equal to the integral of root u du?
Oh, wait, 1 second. Just hold on. Right. That's right. That's what I'm trying to explain to you. You see, the square root of 1 plus sine t is root u. Okay. That part is sorted out. See, that one I used up equation 1. Now I'm substituting equation 2. Equation 2. What is cos t dt? Yeah, is t is du. You are right.
Yeah.
But you need to do one thing at a time. Substitute equation 1 and then substitute equation 2.
Oh,
Right, So now we got, remember root u is just u to the power half, power rule. And we're going to add 1 to the power. If you add 1 to the power, half plus 1 is 3 over 2. And you're going to divide it by 3 over 2 plus c. Now, 1 divided by 3 over 2 is 2/3. U is 1 plus sine t. And to the power 3 over 2 plus c. Okay, great. So that's my final answer. Next
Sorry.
form.
Oh yeah, 2 over 3, yeah, should be because
Yeah,
of the change. Yeah, okay, fine.
Yeah, because I'm dividing it by 1. Remember, you have to divide by the same power. So 1 divided by 3 over 2 is 2 over 3. Yes. Keep change flip. Next type of integral. Guys, every single integral has a different rule, right? So we're done with trig integrals, U substitution. Now we're moving on to a different form of integral. It's something like this. See what I did here now. I don't want to use a C over here because you think that's a different constant. Let's make it a K. Let's call it mx plus b rather, not mx plus c. Straight line. Now, look at this. Look at this integral. Well, a is just a constant. There's a variable here. It's in the denominator. Now, if you remember the form of the integral, remember the form of the integral is very important. So what form is that? The form
Mister,
of the integral, yes.
I think I know what we do the first step.
No, I want to know what form of the integral it is. It's in the form 1 over x dx.
Yeah, so it will be A over M ln mx plus
Good.
c.
That's what I want to hear. It is len form. So this len absolute value of x plus c, that's the form. Anyways, we are going to use u substitution here. So we say let u equal to mx plus b. Then we find the derivative. Remember, I'm taking the d across. Obviously, the derivative, the slope of this function is just m, right? So this is integral. Remember, 1 over, take the a out. Right. So now I'm left with 1 over u, right? And what is dx? It's just du over m. But m is a constant, a is a constant. So what's the answer? I'm going to take a over m, integral 1 over u du. Now you can see the form. Look at the form of the integral. It is the len form. So it's a over m len absolute value of u plus c. What is u? mx plus b. Right, guys? Are we good? You understood that? That was just basic U substitution. It's just that it's a different form. It's not a power rule form. It is the logarithmic form, natural log form. Because that's the rule. Remember, how do you differentiate ln x? Ln x is f prime
1
over
over
prime.
x.
See, yeah, 1 over x. So that's the form. Next integral, E form. Now, this is an exponential form. So when you have rational forms like these, you will most likely to get, ln forms. So 1f. Now, this is in the form integral of e to the power x dx. It is, but now let's make it mx dx. So it's just e to the power mx over m plus c. That's the form of the integral. Now, if you use this rule here directly, but we're not going to use the rule, we're going to use u substitution and see if we come to that rule there. So we say let u equal to 5x du, derivative of 5x is 5. Take the dx from the bottom here, across dx, 5 dx. So I have integral of e to the power u. What is dx? Du over 5. And if I integrate e to the power u, it's just e to the power u. Don't forget the 1 over 5. and is 1/5. Okay, what is e to the power u? E to the power 5x plus c. So whereas c, if I change this m into a 5, it just becomes e to the power 5x over 5 plus c. So you got to remember these forms, okay? So I don't have to keep it like that. I can just say it's over 5. Right, so that was exponential form. Next one. It's an exponential form with another variable inside. So which means you have to go and use a u substitution. And most of the time in exponential form, when you have a e, you always try to make the power equal to u. So what you're going to say, let u equal to x squared. So du is equal to 2x, and remember the dx from the bottom onto the other side. So this is equation 1, and this is equation 2. So let's substitute equation 1 inside. What is x squared? U. And what is x dx? We only left with x dx now. X dx is du over 2. And now we have e to the power u form. Integral of e to the power u is just e to the power u plus c. Don't forget the half there. Now what is u? X squared. And that's my final answer. Are we good, guys? Any questions? So how many rules did we learn? Let's just recap. We have polynomial functions here, right? Still polynomial functions, then trig functions, len form, exponential form, right? That's it. And everything over here is using u substitution. Now let's go over examples. Now we're on to example 2 now. Let's look at these radical forms now. On solve question 2a. Right, so I categorized it for you so you don't get confused. Now let's have a look at these questions. So we got integral of 3x plus 2 dx, all right? So we just say let u equal to 3x plus 2, du is equal to 3 dx. So that's all we have. We don't have any powers and stuff, so it's quite simple. Integral of root u. And what is dx? You have to replace everything. Dx is du over 3. Now we can't integrate just like this. We need to convert this into power form. Take this 1 over 3 out, u to the power half du. So we have 1 over 3, u to the power 3 over 2 divided by 3 over 2 plus c. What is u? 3x plus 2, right? So you got 1/3 here and 2 over 3. So you'll get 2 over 9. 3x plus 2 to the power 3 over 2 plus c. Are we good, guys? It's 1/3 times 2/3. 1 divided by 3 over 2 is 2 over 3. Okay, 2 over 3. 1 times 2 is 2. 3 times 3 is 9. So 2 over 9. Any questions? We good? Quite simple, that one was. Let's look at the next one. Another radical form here.
Teacher, sorry, one question.
Yeah.
Is it was the same formula which used before, which you have before, you know? It was the second or the third
The
one?
first one. Yeah, the first one. It's like
This
like
one,
these
no?
things. Yeah,
Yeah, like this,
it's
like
like
this.
root forms. Root form still comes out to be power forms. Just make sure that everything inside the square root is equal to u.
Okay,
Same
okay.
here. Same here. See, we got a bigger power here and a smaller power on the outside. So make everything, the bigger function equal to u. So make this equal to u. Problem solved. U equal to 1 plus x to the power 5. Du is equal to 5 x to the power 4 dx. Remember the dx is from the bottom. I took it across. Now, we have integral square root of u. What is x to the power 4 dx? X to the power 4 dx
5x,
is d.
5x.
No, not 5x.
Just 5, just
du.
5, just 5.
Du over 5.
Oh, yeah, d over 5. Yeah, you're right.
Yes. So we got 1/5 integral u to the power half du. So 1/5 u to the power half again, u to the power 3 over 2 divided by 3 over 2 plus c, and 2 times, so 2 over 15 I will get here. 1/5 divided by 3 over 2, you can use a calculator and double check that. U to the power 3 over 2 is, what's u? 1 plus x to the power 5, right? To the power 3 over 2 plus c. Okay, guys, quite simple. Let's move on to the next question. So what you can make equal to u here? The bottom piece. Can you see? So let u equal to 1 minus 9x squared. Du is now equal to, yes, derivative of 1 is 0. Minus 9 times 2 is minus 18 x dx. So we have integral 1 over root u. Remember, I left the x out. Now, what is x dx? X dx is from equation 2. Equation 1 is here, right? That's done. I'm substituting equation 2 inside. What is x dx? X dx
du over
is
negative 18.
very good. So I can take that negative 1 over 18 out. What is 1 over root u? U to the power negative half. Okay? Power rule again. So now what we have is negative 1 over 18. Add 1 to the power, u to the power half, divide by half, plus c. So now you're going to have 1 divided by half is 2. 2 over 18
Over
is
18.
negative. 2 over 18 is negative 1 over 9. What's u? U is 1 minus 9x squared to the power half plus c. To the power half, you can put this in radical form. You already know that inside over outside, right? So that's square root of 1 minus 9x squared plus c. Okay, just written in a neater form. Okay, that's basic stuff. 1 minus 9x squared, right? Great. So we have completed everything from the radical form. Let's look at trigonometric form. Right, so I'm trying to do enough examples so you understand everything. So third part is trigonometry. So you got all the ways to do radical forms, use substitution. Look at this. You can just use a rule and say the answer is, what's the answer? Negative cos, right? Negative cos 7x over 7 plus c, or we can use u substitution, okay? So we say 7x equal to u. Du is equal to 7 dx. So now we have integral of sine u. What is dx? Du over 7. And the integral of sine u is negative cos u, right? Take the 1 over 7 out. Negative cos u dot negative cos u plus c. Okay, so we can say negative
So
1
Sunny,
over 7. Yes.
is the one above correct? Because 118 times 2 over 3 is not 1 over 9.
No, no,
No,
no.
it is.
Wait,
It
how
is,
did
it
we
is.
get half? Oh, it's negative half. Oh, yes, sorry.
It's half, half.
Yeah,
So 1
sorry.
divided by half is 2.
Because
2
it's
over
1
18
over
is
root 2.
negative.
Okay,
Yeah.
okay. Got it. Yep.
Oh,
Sorry.
great. Look at this one now. This is cos. What is u? U is 7x plus c. Right, so this part is also solved. Next part, next question.
Teacher, we can use by 2 ways, yeah? Solving this kind of questions, the trigonometry.
If you remember the rule, you can just take you can just go from this step to the final step. If you remember the rule, you don't need to write out. You can just say negative cos 7x over 7 plus c. You can just say negative cos 7x over 7 plus c. That's it. Okay,
Mister,
same thing.
I have a
Yes.
question.
Yes, what's the question?
This was what used to mix me up last year. I
Mm.
didn't know when to use U substitution and when to use like normal derivative functions. Like I
Okay.
do understand U substitution, but I don't understand now like what's the difference between it and chain rule? When do we use it exactly in
Chain
question?
rule is for differentiation, and U substitution is reversing the chain rule.
So when do I use U substitution?
U substitution you only use when you are integrating. Example, if I have to differentiate this function here, I have to use chain rule. If I differentiate this function, I must get the inside answer, which is sine 7x. We'll do it for this example, okay? Look at this
So
one.
I'm saying whenever you have sine or like something and then you have an inside function that has brackets, we use U substitution.
Yes, of course. See, like
Okay.
this one. It doesn't have to be sine. It can be any other trig function. Look at this. We have x cubed plus 4. So we have to make the complicated function equal to u. So u is equal to x cubed plus 4. du
Then you
is equal
differentiate
to
that 3x.
3x squared.
Yeah,
And
yeah. My
move
bad.
the dx is du dx. So move the dx from the bottom here. Right. Now, we have integral of sine u. What is x squared dx? What is x squared dx? Great. That's just du over 3. And this is basically elementary stuff, right? So now if you integrate this, what is integral of sine u? Take the 1/3 out.
Sine
Is
of x cubed plus 4.
no. What's the integral of sine u? Negative
Negative cos.
cos.
Oh,
Yes.
yeah. Negative cos. Yes, yes. I forgot.
Right. So now we got negative 1 over 3. What is cos u?
X
Cos.
cubed plus 4.
Yes. Plus c. And that's my final answer. Look, if you have to differentiate this, you have to get the inside, right? Let's try differentiating this. Let's say this is the bigger function f of x. And if I find the derivative of this, okay, let's just call that f of x. Let's find the derivative. Let's call this the f of x function. Right, so if I differentiate this, you know we don't differentiate negatives. So leave the negative 1 over 3. What's the derivative of cos x cubed plus 4? Derivative of cos is negative sine. Right? And now you know the rules for derivatives. You differentiated that. You have to differentiate the inside as well. If you differentiate the inside, you get 3x squared. And guess what? The negative 1/3 and the 3 and the negative cancels out. So what's the answer? X squared sine x cubed plus 4. That's the inside. Okay? So we are getting the answer, which is x squared sine. And that's how you check whether your answer is correct, is to differentiate your final answer and see if you get everything on the inside of the integral. Okay? Great, guys. Look at the next one. Remember I said you can't integrate singles. So, but now over here, I'm integrating a single, which is tan x. How would I integrate tan x? To integrate tan x, we're going to change tan to sine over cos. And this is an amazing integral, right? So make cos x equal to you, make the denominator equal to u, because the derivative of cos is sine. It can cancel out. Let u equal to cos x du. What's the derivative of cos x? Negative sine x dx. Are we good? Equation 1, equation 2. Now, what is, I can substitute equation 1 first, or I can substitute equation 2 first. It doesn't matter. Let me substitute equation 2 first because I can see sine x dx here. And I want to know what is sine x dx. Sine x dx is negative du. So times negative du integral 1 over, what is cos x? U.
U.
Yeah. And what's the integral of 1 over u? Ln. Don't forget the
ln.
negative outside. Yeah, negative ln absolute value u plus c. Okay. Now see how this answer transforms. So this answer is negative ln absolute value. What's u? cos x plus c. Now see, there's multiple ways to write this out. You can see this negative, rules of logs, you can take this negative up on the power. So what is ln a to the power p? Is p ln a. Okay, so remember this basic rule here.
So
That's what,
how did you
yeah.
get the log rule from sin x over cos x?
Because we got the form, the integral form is 1 over u du.
Teacher, we can rewrite this one by 1 over ln cos absolute value cos x plus c, yeah? 1 over
Yeah.
that.
No, yeah. So it's going to become not 1 over. The negative goes to the power. So it's ln cos x to the power negative 1 plus c. And what is cos x to the power negative 1? It is 1 over cos x. Okay?
Yeah, that's why I asked
And
again.
what is 1 over cos x? Sec x. So that's the
Oh
answer.
yeah. Great, yeah.
Ln sec x. Let's see, that's your final answer. But if look, when you are doing calculations, you're allowed to leave it in this form, okay? But if you do see this form, you know what that is, integral of tan. It's just that you're just getting rid of the negative there, okay? Great, guys. That's a nice question there. Moving on to this one. What's happening here? Question, the fourth question. What's happening here in this trig? All right, let's see. Integral of sec squared 4x, okay? Let's
It's
make
1 over
4x.
sinus square, yeah? Can you rewrite it like, is that allowed?
No. This is where, what was I doing before? I was integrating singles, right? What am I integrating? Double. So you
Oh
got the
yeah.
integral of, you are integrating in pairs. What's the integral of sec squared x dx? The
10,
answer
10,
will
10.
end up with tan x, but not tan x. It's going to be probably tan 4x something something. So that's why I need to put it in that original form, right? So I need to put it into that form because remember the integral is in this form. Sec squared x dx is tan x plus c. But now I can't have tan x because I've got this here as a function. That's why I need to use u sub, right? So I need to u sub this. So let u equal to 4x, du is equal to 4 dx, differentiation. Then we have integral sec squared u. What is dx? Du over 4. All right, so not bad. The integral of sec squared u is tan x, is tan u. And don't forget the quarter outside. Quarter tan u plus c. And what is u? 4x. So it's just quarter tan 4x plus c. Great. Amazing. Right, guys. So that's done with that question. Let's look at rational forms, rational and log forms. And now we even have a definite integral in there. Great. Now remember the dx is just moved from here to there because remember that was a 1 there, right? This is not an error. The dx is just moved from here to there. What is 1 times dx? Dx. So let's take this out. You can also write the integral in this form. Dx over this. Are we good? So we're going to say let u equal to 4 minus 2x. Because this is the bigger function. So du is equal to negative 2 dx. Okay, guys. Equals. Now, let me write this. Remember, this is, what is 0 and 1? Those are x values, right? X values, x values. Now, if x is equal to 1, if x is equal to 1, then what's the value for u from this equation? Because I need to change the boundaries. I'm converting dx to du.
2. 2, no?
If x is 1, u is 2. Good. And if x is 0, the value of u is
4.
4. Yes. So 0 is giving me 4 and 1 is giving me 2. Now, this is a thing now. You see, this is just a lower boundary and upper boundary. It doesn't mean that the lower boundary always has to be smaller than the upper boundary. It just bounds off integrals. That's it. It's fine if it's from 4 to 2. Now, question is, over here, we're changing everything. What is dx? Dx is du over -2, okay? That's dx. And what are we left with? 1 over 4 minus 2x, so 1 over u cubed. Are we good, guys? 1 over u cubed, that was u. Now, because you have converted the bounds for integrals, you can forget about the previous question. This is your question now. Solve this. You just made a new question by changing the boundaries. So this is -half. Let me take the -half out. Integral 4 to
ln.
2. No, not ln. U to the power -3. It's only ln if it's in this form, 1 over u du. That's
Oh,
the
yeah,
ln
fine,
form.
yeah.
This is a rational form, right? So that's ln. But if you have this form, it's just power rule, -3 du. This is easy. So we have -half. Integrate this. U to the power -2 over -2. No plus c, okay? And this is when u value is equal to 4 and when u value is equal to 2. So -half, open bracket. Now, yeah, that's the problem now. You're going to have an issue here. Let's do this. Let's take this -half out from here as well and make it positive quarter. So you got a -half here in this integral, and you got a -half. You can multiply these two constants out, it becomes positive quarter. And u to the power -2 is 1 over u squared. And this is from 4 to 2. Now, we got quarter. If you substitute 2 inside, you're getting 1 over 2 squared is quarter minus the lower boundary. Upper boundary is quarter. Lower boundary is 1 over 16.
Teacher, one question, sorry.
Yeah.
It will be same because we let u becoming the another function,
Yeah.
no?
Yeah.
It's
We
correct,
change the
yeah?
boundaries. Yeah, we change the boundaries. The reason why we're not substituting this thing back into x is because we change the boundaries. If you didn't change the boundaries, you need to substitute it back into x and then substitute the x. You'll get the same answer. Okay, so this is 4 over 16. So I'm going to get 3 over 16 here, right? Is that correct? Quarter minus, remember, times 4 and times 4 over 4. So 4 times 4 is 16, 4 minus 1, right? So that's correct. And then 4 times 16 is 64. So my final answer is 3 over 64. You can double check this answer by putting it into the calculator, the original function. So you can just integrate like this, integral. You're allowed to use a calculator and make sure you have this integral calculator with you. 0 to 1, I'm going to put the original function, right? So 1 over 4 minus 2x alpha x, close bracket, to the power 3. Everything looks good here. 3 over 64. Great.
Teacher,
Are we good,
sorry,
guys?
one question. If you put the dx instead of 1, it will give you us error. If you put instead of 1 dx and take away the dx.
Yeah, no, you can't take away the dx because then what variable are you integrating with respect to?
Yeah, that's why I'm asking, yeah.
No, you have to keep the dx. Yeah, the dx has to be there. Any
Yeah.
integral, if you're solving any integral, you must have a dx or a du or d something. It means you're finding the antiderivative. You must have a d there. All right, guys, almost there. It looks like we have to go another 15 minutes, but it's fine. All right, let's solve b. B has no boundaries. Remember, the ones with the boundaries are nice because you can double check them on the calculator whether the answer is correct or not, because you will always get values. Let's try to solve this. Remember, if you can remember the rule, the form. Remember, I integrated a over mx plus b dx. If you remember this form, then you will remember that I had a over m len absolute value mx plus b plus c. So you can do this. What's a? 1. So I'm going to get 1 over 2. It's like 1 over the slope. That's it. 1 over 2 len absolute value 2x plus 3 plus c. That's my answer. But just by remembering the form. And this is very important to remember. Are we good, guys? That's quite simple because it's directly from here. I did it in the first example. See? See what it became? It became a over m, the constant over the slope, len of this, len of the bottom function plus c. Yeah, that's right. You can just revisit that. Right, next question, guys. Right, so in the next question, okay, we have a rational function, so we will attempt to make the denominator equal to u, okay? So let u equal to, and you can see the derivative appears in the integral, so problem solved. Let u equal to x squared plus 5. So du is equal to 2x dx. We can see 2x dx, that is just du. And what's the integral of, and what's x squared plus 5? U. So what's the integral of du over u? Is the same thing as saying integral of 1 over u du. That is just learn form. Okay? So this is len. What is u? X squared plus 5. Now we can clearly see, now this is very important, because you can clearly see that x squared plus 5 is always positive, is negative, it can never ever be negative answer. You can drop the absolute value now, only if you are sure that it's always positive. Okay? Like in the previous examples, I wasn't sure. You see, 2x plus 3 can be positive or negative, right? X can be any number. Over here, if x is any number, this answer x squared plus 5 will always be positive. Then you can drop the absolute value. Anyways, let's move on to let's look at the exponential types of integration. Right, so we have an exponential integration. So we always make the power equal to u. So let u equal to 2x plus 7. So du is equal to 2 dx. The derivative of 2x plus 7 is 2. So now we have integral 3. Don't worry about the 3. You can take the 3 out. Or you can just keep it inside. This is e to the power u. What is dx? Dx is du over 2. Okay? We're solving for dx, all right? So dx is du over 2. And what's the integral of e to the power u? It remains the same. And what is u? Substitute the x back. Okay, guys. You understanding? Any questions? It's quite simple. Let's move on to the next.
No any questions, sir.
You have a question?
No any questions, sir. Sorry.
Right. Look at the next one. Quite simple as well, because see, you just integrated something like this. What happened? Look at this. I don't want to go through the entire process of u substitution. See, you, think about just integrating e to the power 2x plus 7. Don't worry about the 3. What was your answer? It was e to the power 2x plus 7 over 2. So obviously over here is going to become e to the power 3x over 3. You can try u substitution here, but this is just e to the power 3x over 3 and substitute 0 to 1. Right, so if I substitute 1 here, I will get e cubed over 3 minus, if I substitute 0, e to the power 0 is 1, 1 over 3. I can take out 1 over 3 as a common factor, and I'm left with e cubed minus 1. You don't have to do that. You can just get a decimal value after that, okay? And that's my final answer. Are we good, guys? And remember, I did tell you, how do I integrate e to the power mx? Remember the form? e to the power mx, the integral is just e to the power mx over m plus c. Okay? Even if you have a linear constant here, like plus b, it's fine. So if I put a plus b here, it's fine. Because when you're finding the derivative of this, you're going to get m. You can see. So that's like a general rule you can remember. So remember, for each type of integral, there's a different rule. Let's look at something like this now. This is nice because trig and e combined. More like a combination rule, but still, you still got to do u substitution. And what did I tell you about u substitution? Try to make the power equal to u. So I'm going to say let u equal to sine x. What is du? What's the derivative of sine x? Just cos x. Derivative of cos is negative sign because it starts with a c, right? So we have that. Do we have cos x dx in the integral? Yes. Cos x dx, great. Cos x dx is du. So basic integral, e to the power u du. So sometimes the integral can be complicated, but when you use u substitution, it becomes much more easier. An integral of e to the power u is just e to the power u plus c. And what's e to the power u? E to the power sine x plus c. Easy, guys. Are we good? Any questions?
No,
This
sir,
was
thank
very
you.
easy.
No, we're good.
Right. Right, let's move on to using symmetry for integrals, right? Uh, how do I use symmetry to solve integrals? So even and odd function. Now, if a function is even, now I'll explain this to you by means of graph, because we did areas, right? So if you're thinking about the x to the power 4 plus 3, it's more like a function which is a little bit quadratic, but obviously it goes much faster, right? So this is the function, and we try to integrate from -3 to 3, right? So I'll put -3 here and negative and 3 here. You can clearly see if you integrate from -3 to 3 is the same thing as saying 0 to 3 times 2. Okay? So this is the same thing as saying 2 times integral 0 to 3 of x to the power 4 plus 3 dx. Now, when does this happen? When the function is even. How do we know whether this function is even or not? So remember, f of x is equal to x to the power 4 plus 3. If I put negative x, it will still become x to the power 4 plus 3, because negative x to the power 4 is x to the power 4 plus 3. So this function is even. Why it is even? Because f of negative x is f of x. Right? It's symmetrical about the y-axis. Anyways, you can solve this integral 2 times, solve this x to the power 5 over 5 plus 3x, right? 0 to 3. If I substitute 3 in here, 3 to the power 5. 3 to the power 4 is 81, 243. Can you use a calculator, guys? Come on. 3 to the power 5, 243, right? 243 over 5 plus 9. No, 3 times 3 is 9, yeah, plus 9. And minus, substitute 0 there, minus 0 plus 0, right? Lower boundary. So now you can put all this in the calculator, 2 times 243, whatever, I mean, like 248, 486. Right, use calculator and get the answer, okay? It's fine. Move on to the next problem. What happens when we have an odd function? and we integrating over negative to positive boundaries, right? For an odd function, next function I gave you is odd. How do we know that this function is odd? Look at the sine x and 1 plus x squared, right? Very difficult integral if you try to solve. It's not even going to use u substitution. It's not very difficult to solve. But the reason why it's given is because of the type of function. So we say f of x is equal to sine x over 1 plus x squared. If I put negative x inside here, right? You'll get what sign of negative x? Negative sine x over 1 plus x squared, right? You see this negative can come out, it becomes negative f of x. So this function is
Why did you
odd
do this, mister? Why did you do
Um,
f of negative x?
because that's how you check whether the function is even or odd. Okay?
How do you check again?
To check whether the function is even or whether the function is odd, you need to substitute negative x inside the function.
Okay,
If
so
f
here
of,
we substituted negative x, we got a different solution.
no, we didn't. We got negative sine x over x squared. But what is sine x over 1 plus x squared? It is negative f of x. Because sine x over
Oh,
1 plus
okay,
x
okay,
squared.
okay,
So
okay.
that function is odd. And the integral of an odd function, you're going to say integral. How are you going to do this? You're going to say this is sine x over 1 plus x. You got to show that this is an odd function. You're going to say this is an odd function. Right, so we prove that f of x is odd. So we're going to say integral negative a to a of odd function, right? Dx, the answer is always 0. That's it. The answer for this will be 0. You can try it out on the calculator. Now, why is this the case? I'm going to explain to you. Take a simple example. Note. I want to find the integral from negative 1 to 1 of x dx. It's a simple equation, isn't it? I'm telling you now that the answer will be 0. Why? Because x is an odd function. How do we know that? It's a straight line, okay? And see what you're trying to integrate. You're trying to integrate from negative 1 to 1. It's going to cancel the areas out. You see, you're going to integrate from negative 1. Remember, because when you're finding this, if you're integrating from negative 1 to 1, you kind of like finding the area. This area will be negative because it's below the x-axis, okay? And this area will be positive. So if you add both the areas, it will become 0. So let's just integrate and I will show you. So integral of x is x squared over 2, right? X equals negative 1, x equals 1. So if I substitute 1 inside the top function, I'm going to get half, and substitute negative 1 in the same function, in the antiderivative function, I'm going to get half. That's the answer, 0. All right, guys, just 1 second.